Thanks very much. Yeah, my name's Sam Cockrell. I'm Chief Executive of Libertine, and we're looking to raise £600,000 of EIS equity. Now, Libertine makes linear machines for power and motion. These are linear electrical machines. Most electrical machines rotate and ours reciprocate. The other difference is we integrate linear valves, linear bearings, preload devices, and other stuff with our electrical machines that makes them a very useful platform technology for a wide range of applications. So you can think of this a bit like a smart sort of alternative to a hydraulic or a pneumatic cylinder. This platform technology can be used for linear actuators, for linear pumps, for linear gas expanders and compressors. Perhaps the killer application, though, is in a type of engine called a free piston engine. Now, in a free piston engine, there is no crankshaft. The piston is free to move, and it's governed by a linear electrical machine, by our technology. Now, a free piston engine is not a new idea, I have to say. So here are some examples of a free piston engine containing products. A power station on the top left, a French Navy vessel on the top right, a prototype train, a prototype car made by General Motors in the 1950s. But these pictures are all in black and white. You'll notice there are no free piston engines in the vehicles outside, and there are no free piston engines in the basement running the lights and the heating in this place. And the reason for that I can explain with reference to the little picture in the middle. You can see here, as I've described, this is an internal combustion engine, but it doesn't have a crankshaft. In the middle, there's a linear electrical machine. And one of the things that happens when you get rid of the mechanical crankshaft and drivetrain is you no longer have absolute determinism of where the piston is at any point in time. So if you want to run a combustion process efficiently, cleanly, with low emissions and very reliably, the electrical machine needs to do what the crankshaft did and give you very good motion control of exactly where the piston is at any point in time. Now, the good news is a lot of car companies and other startups have woken up to the enormous potential benefits of free piston engines. Companies like Volvo, Toyota, General Motors, Peugeot have all piled in with significant investments in the last decade, looking to realize the efficiency benefits, perhaps a third more power from the same fuel going in. Emissions benefits, these are potentially very clean engines. They scale down. You can make a tiny engine without the complexity of a conventional engine. The packaging is great. The power density is pretty good. People see a lot of potential benefits, but the principal technology barrier has not been cracked yet, which is how do you control where the free piston is if you haven't got a crankshaft? Now, part of the reason for this is this problem requires a lot of different types of engineering to talk to each other, the combustion engineering and the mechanical engineering of that integration, the electrical engineering and the electrical sort of power electronics, together with the software and the control. And historically, these different types of engineering have been sitting in different camps. Different engineers are typically experts in their own space. And the multidisciplinary approach to engineering is not something which is especially straightforward to do. Fortunately, this is something that the UK does especially well, which is demonstrated, really exemplified by our global leadership in the motorsports industry. To make a car win, you have to optimize across multiple different areas of engineering: manufacturing technology, materials technology, control, software, combustion technology. All of these things together cannot be optimized individually. You have to have them brought together under the same roof, into the same design team, often in the mind of the same person. We do this very well in high-performance engineering in Formula One. And this is the expertise, this is the cluster, these are the supply chains that Libertine taps into. I met our Chief Technology Officer, who's also here with us today, when we both worked for Cosworth. I was making IndyCar race engines. Ed was making Curse systems for Williams F1. We also benefit from a pretty good stable of advisors, including Rob Margits from the Energy Technologies Institute, Robin Saxby, previously from ARM, and Derek Shepherd, who's was main board director at Agreco. We've made very good progress, raising £2.5 million of funds. In the last year, we've generated about £250,000 of revenues. We sell technical development services, we sell IP, and we also then sell linear electrical machines. And with our funding we're looking to raise, we will expand our pipeline of revenues and our pipeline of customers. We'll recruit a business development director to help us do that. We'll support some grant funding that we've got available at the moment. And we're expecting through that to break even in 2019, to scale revenues very rapidly to about 10 million by 2020, and to have an exit possibly to a corporate VC in 2021. So just to close off then, some examples of our technology here. A test actuator which is being used by Anthony Best Dynamics for automotive test systems. On the bottom right, a gas expander for heat to power applications. On the bottom left, a free piston research engine. And on the top left, my favorite quote. This is from one of the world's experts in combustion engine control systems, who's done some work in free piston engine control and who looks to what we're developing and sees our approach to delivering motion control in a platform technology that free piston engine developers can use to bring forwards free piston engines as a commonplace power generator technology in transport and distributed power. He sees our approach as the technology that the world is begging for. If you want to have a chat, we're just outside, so I look forward to speaking later on. Thank you very much.